show you that this particular choice for delta does indeed work, I need to formally prove it. So let's show that this particular choice for delta works. So given an arbitrarily small epsilon value that's strictly positive, we will let our delta be the minimum of these two values between 1 and epsilon over 2. Now if I make the assumption that the absolute value of x minus, I forget already, you guys, is it 2? Is less than delta, but strictly positive. And if I can show you, the reader, that the absolute value difference between my f of x well, if I can show you that this is strictly less than epsilon, then I think via my epsilon delta definition, I've proven to you that the limit of that quadratic expression is equal to -7 as x goes to 2. So, you ready? Let's put the pieces together. That's all I'm doing. And putting the pieces together, repeating some of my algebraic steps, perhaps. I guess I've got the absolute value of this trinomial. And I can factor. And here too, the absolute value of a product is a product of two absolute values. Oh shoot, you guys, I have to take a break. Can I pull out another piece of scratch paper? And pulling out my other piece of scratch paper, if it is the case that the absolute value of x minus 2 is sandwiched between here and here, and I choose that particular value for delta to be nothing more than, I don't know, what do you guys think? Maybe a 1? Then I do think that suggests that the absolute value of x minus 2 is between 1 and -1. I do think it implies x minus 1 is between here and here. And I do think it suggests an absolute value is x minus 1 is just simply less than my positive 2. What do you think so far? And that being the case, let's come back. Because I see the absolute value of x minus 1, and I'm assuming it's less than 2. So I will say that this absolute value of s is strictly less than 2. But here's another x minus 2, and I'm assuming it's less than delta. And delta is the minimum of these two values. Let me just choose the second one. Is that legal? Like, what if epsilon over 2 is not the smallest?
Don't you have to do 2 cases for this?
Absolutely not.
No?
Here's why. I didn't think it matters that epsilon over 2 might be the largest. If it's largest, that inequality still holds. It just means the number is even larger than I needed it to be. It's just that with my arithmetic, I get a tad bit of cancellation. This is nothing more than epsilon.
What if the second one isn't the smallest, can you just take the first one then, if it's the smallest?
Yeah, I really could. It's just that I wouldn't get a nice clean epsilon again. And I want that nice clean epsilon. But it's okay if that's not the smallest, because I think that product is still going to be an upper bound for all the other mess before. Therefore, I think I have proven that the limit of my quadratic expression, this one right here, is indeed equal to -7, as x does this thing. Was that a 4? No, it was a 2. And I've proven what I wanted to show. What do you think?
That's great. We just have to do 2 cases.
What's that?
Chuck had us do 1 and epsilon over 2, so we prove it in 2 different lines.
Well, he's already stated that it's going to be the minimum.
Yeah, I know.
Either of those.
We stated that it was the minimum, but then we...
I'm not saying there's anything wrong with breaking this up into 2 cases. I just want to be efficient and elegant with my proof.
So this does account for both cases?
Absolutely.
Okay, I
And
just
again,
wanna be sure
that's what I'm
that,
talking about. What if I'm wrong? What if that epsilon over 2 is the larger two values? Doesn't make any difference because this is an inequality. And that larger expression's still going to be an upper bound for what I have. I don't need to accommodate for the second case.
okay.
Well, at least with the way I organize my work. Now, I think that's more sophisticated than that.
So I have a question, not really related to this problem, but since you were mentioning real analysis earlier, is
Yes.
it basically calculus this way, just the same stuff?
Yeah, or you can think of it this way. Some people treat that discipline of real analysis, particularly when you study it at the university level within the bachelor's degree range. You can think of real analysis as proving all the calculus.
Yes.
There's a lot of the calculus that you and I have not proven. There are a lot of theorems, even before your 4 degrees over, you still can't prove. You won't be able to get it to graduate school like maybe the intermediate value theorem, those existence theorems. They're so sophisticated, yet there's a lot of machinery behind them to prove them true.
You can't prove intermediate value theorem
At this level,
Yeah.
no, we don't have the tools. I don't know if you guys notice this, but even in the algebra courses, we tell you the natural numbers are 1, 2, 3 on up. We tell you integers are the same thing, with negatives and 0. We then say that the rational numbers are numbers that can be expressed as ratios of integers, they're fractions. And then we hand wave and we say, oh, the real numbers are just the rationals and irrationals put together. That's hand waving. And you have never seen a formal definition of the real numbers. In a sense, they don't have a formal definition. We can only talk about their qualities. And if you take a year-long course called real analysis, through that course, you develop what the real numbers are. It takes that much mathematics just to know what the real numbers are. They're that complex.
So, do we have time for a multivariable one? Or?
Thank you very much, Mr. Callaghan. Okay, so that concludes this meeting. I will send out an email as far as